Everyone, welcome back, and let's provide the solution to this math problem. We have k squared minus 2 raised to power 2 is equal to k plus 2. So what is the value of k? Solution. K squared minus 2 raised to power 2, this is equal to k plus 2, okay? So now applying the algebraic identity that states that a minus b squared, this is equal to a squared minus 2ab plus b squared, will have k squared minus 2 squared, this is the same as k squared minus 2 multiplied by k squared multiplied by 2 plus negative 2 squared, which is equal to 4, okay? So this is k raised to power 4 minus 4k squared plus 4, this is equal to k plus 2, okay? So we take k plus 2 on the left hand side, so that we're going to have k raised to power 4 minus 4k squared plus 4 minus k minus 2, this is equal to 0, okay? So that we are going to have k raised to power 4 minus 4k squared, 4 minus 2, you're going to have minus k plus 2, this is equal to 0, okay? Now, if you check here, we can be able to factor out, this is k raised to power 4 minus 4k raised to power 2. So we can factor out k squared, so that we're going to have k squared minus 4, okay, minus, this is the same as k plus 2, okay, this is equal to 0, okay, alright, so that we're going to have k squared. Now we can express this as k squared minus, this is 2 squared, as you can check, this is 4 is the same as 2 squared minus, this is k plus 2, this is equal to 0, okay? So now if you check this part, this is the difference of two squares expressed as a squared minus b squared, which is the same as a plus b, a minus b, so that this is k squared minus 2 squared can be expressed as k plus 2 and k minus 2, okay? So we plug in here, so that we'll have k squared into the bracket, we'll have k plus 2 and again k minus 2 minus, okay, this is k plus 2, this is equal to 0, okay? Now as you can see, we have again k squared into the bracket k plus 2, this is k minus 2, okay? Now this is minus, this is the same as k, remember this is k minus 2, this is equal to 0, okay? So k minus 2 is common, remember this is common, we can factor out k minus 2, so that we will have, this is k squared multiplied by, this is k plus 2 minus 1, okay, this is equal to 0, alright? So that's, as you can see, k, the first value of k, this is k minus 2, this is equal to 0. So that means that the first value of k is equal to 2, okay? That is the first value of k, that is k1 is equal to 2, okay? So that the second part, we have k squared multiplied by k plus 2 minus 1, this is equal to 0, okay? So that we'll have k squared times k, this is k cubed plus 2k minus 1, this is equal to 0, okay? Now as you can see, this is actually a cubic, this is a cubic polynomial, okay? This is a cubic polynomial, and you can be able to apply a lot of methods to solve for this cubic polynomial, okay? But we are going to apply the simple synthetic division to solve the value of k given this cubic polynomial as follows. We have this cubic polynomial and we want to solve for the value of k. Remember, we want to reduce this cubic into a quadratic equation. So the first thing to do, we think of a value of k. That's if you plug in that value of k will satisfy the equation. So we can think of k as equal to -1. So if you plug in -1 in our polynomial, cubic polynomial, you're going to have -1 cubed plus 2 into the bracket -1 squared minus 1 should give us a value of 0. Okay, so that we're going to have -1 cubed. This is equal to -1. This is -1 squared, which is 1 times 2 to be 2 plus 2 minus 1. This is equal to 0. So this is -1 plus 2 minus 1. This is again supposed to give us 0, and it's true, and that's already gives us the value of k2 is equal to -1. Okay, now applying the synthetic division, we're going to have, we can just plug in our values as follows. Now we have -1, and then now we can have the coefficient of k of the cubic polynomial. This is the coefficient here is 1. The coefficient for k squared is 2. Now we don't have k, but even though it's not, we can take it to be 0. And then we have the constant, which is -1. Okay, so now we're going to have, we can drop this one here, so that we're going to have 1 times -1. This is -1. If you add, we just add, so that this is 2 plus -1. This is equal to 1. And again, you say -1 times 1, which is equal to -1. If you add again, this is supposed to give us -1. And then you say -1 times -1, which is 1. So you'll have 1. So you add 1. So this is -1 plus 1. This is equal to 0. Okay. Now these are the coefficients. Okay. These are the coefficients of the quadratic equation. Okay. These are the coefficients of the quadratic equation. Okay, and remember our quadratic equation is in the form of ax squared plus bx plus c. This is equal to 0. Okay, so that we are going to have k squared plus, remember this is the first coefficient. The first coefficient of k, we have 1 plus k minus 1. This is equal to 0. This is the format for quadratic equation, but in our case we are dealing with k, so we have k squared plus k minus 1. So what is the value of k? Now applying the quadratic formula, we'll have k is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2 by 2a. Okay, so that from our quadratic equation, our a is equal to 1, our b is equal to 1, and our constant is equal to -1. Okay, so that we'll have that is -1 plus or minus the square root of 1 squared, that is 1 squared minus 4 times 1 times -1, divide everything by 2. So that now we're going to have -1 plus or minus the square root of 5 divided by 2. Okay, so this means we have -1 plus or minus the square root of 5 divided by 2. Okay, so that means that we have the third value of k, that is k3, is supposed to be equal to -1 plus the square root of 5 divided by 2, and this one is equal to 0.62, and we have k4, which is -1 minus the square root of 5 divided by 2. This is equal to -1.62. Okay, so these are the 4 solutions. We have the 4 solutions whereby the first k1 is equal to 2, K2 is equal to negative 1, K3 is equal to 0.62, and our K4 is equal to negative 1.62. These are our 4 solutions. Thank you for watching and kindly subscribe, my good people.